day, class. Today we're starting chapter 4, which is solving exponential equations, and lesson 4.1 is dealing with the exponent laws. So this should be mostly a review of grade 9, 10, and 11. And here we go. Let's just recap, folks. The power is the whole thing. I apologize. I'm seeing if my smart board will work here. There we go. The power is the entire expression, and the power contains the base and the exponent. Okay, so the exponent is how many times the base is repeated. So if I was to put this in expanded form, you would write 5 times 5 times 5. And if I asked you to solve it in numerical form, you would tell me it's 125. All right, so taking a look here again, exponential or power form is where you see the base with the exponent. Expanded form is where the base is multiplied the number of times of the exponent. And numerical form is the answer itself. So that's a little background on your proper forms of exponential and numerical and expanded forms. Now we'll go over some exponent laws that'll help us to evaluate or to simplify our exponential equations or expressions. All right, the first one is the multiplying the powers. So to multiply the powers of the same base, you keep the base, and the important thing here is to add the exponents. Here is the law. We'll do a couple examples here so you can see what it looks like. So if I have 3 to the exponent 5 times 3 to the exponent 9, it's going to equal 3. That's the base, and you're going to add the exponents. So to the power of 5 plus 9, which equals 3 to the power of 14. Second example, let's just have a fraction here for a base. So 2/3, all raised to the power 4 times 2/3. Let me make that a better 2, sorry. All raised to the power of 6. Again, our base in this case is 2/3, and we're going to raise it to the 4 plus 6. So it's equals, simplified, it'd be 2/3, all raised to the exponent of 10. Good. Let's take a look at the division law, ladies and gentlemen. For the division law, you keep the base the same and you subtract the exponents. Okay? So if I wrote down 23 to the exponent 30 divided by 23 to the exponent 10, that's going to equal 23 to the 30 subtract 10, which equals 23 to the power of 20. Okay. Another example we could see is m to the power of 5 divided by m to the power of 3. Again, that's division law, so it tells us we're going to subtract the exponents, keeping the base the same. So it's going to be m to the power of 2, or m squared. Great. Taking a look now, folks, we're going to do the power of a power law. That's going to be one exponent raised to another exponent. That's what that means. So remember, you're going to keep the base the same, and you're going to multiply the exponents. So in this case, for an example, if I had 5 to the power of 3, but that's all raised to the power of 6. The base is 5, and it's going to be to the power of 3 times 6. That's going to be 5 to the power of 18. Okay, second example I'll do over here, example number 2. If I have 3/4, all raised to the power of 5, and then I've got that all raised to the power of 4. Again, my base is 3/4, and I'm going to raise it to the 5 times 4, which equals 3/4 raised to the power of 20. Just remember, folks, that 20 applies to both the numerator and the denominator, because the base is included with the numerator and the denominator. That's what makes the base up. All right, let's look at some other laws on the second page here. Let me flip. Next is the zero exponent law. Anything raised to the exponent 0 is 1. Okay, I'll explain the law. So here's my explanation. So if I explain it this way, okay, so say I had 6 to the power of 5 divided by 6 to the power of 5. Well, that's our division law. That's 6 to the negative 5. So 5 subtract 5, which equals 6 to the 0. But 6 to the 5th divided by 6 to the 5th equals 1. All right? Apologize for that interruption. Sorry, guys. All right, so taking a look here, folks, we have to be careful with what's in the base. So when I take a look at some examples, if I have 5 to the power of 0, that equals 1. Okay, that's the first example. Second example, if I have -5 as my base raised to the exponent 0, that also equals 1. But where you have to be careful is this third example. If I write -5 all raised to the power of 0, be careful here because the negative's out front. It's not part of the base. Because the base that's raised to exponent 0 is really just 5. So in this case, it's going to be negative times 1, which equals -1. So all you have to do is remember, folks, if the negative's inside the bracket, like example 2, that's fine, it's going to be 1. But if it's outside, like in this third example, then you've got to be careful that it's going to be -1. Okay, next we're moving on to the negative exponent law. It is never proper form to leave a negative exponent, so you make it positive. To do that, you take the reciprocal, or you flip the fraction if there's a fraction. So for example, if I have, for example 1, 5 to the power of -2, that's going to equal 1 over 5 to the power of 2, because it's positive. Look for example 2, this may be looking different because the base is actually a fraction. So 4/5 is my base. I'm going to raise it to the -3. Again, to form the reciprocal, you flip the fraction. So 4/5 becomes 5 over 4, and then it's raised to the positive exponent. Okay, moving on into more rational expressions. This is more what we dealt with in grade 11. Okay, if we take a look at rational exponents, sometimes they're in what we call radical form, and sometimes they're in exponential form. So this is your exponential form, guys. Okay, and these two are what we call your radical form. This is more, I'll just say the last one is the complete radical form. This one's a mix, so I'm just going to erase this one. Okay, and this is in your radical. And you can switch, as you learned from last year, you can switch one form to the other depending on how you want to solve this expression. Okay, so say I give you 8 to the 2 over 3. Just remember that when you've got a fraction, the top part is the actual exponent, whereas the denominator part of the fractional exponent, that is actually what we call your root, folks. Okay? So the way to express this, if we change that to radical form, is first of all, my base is 8. I'm taking the third root of it, and then I'm going to take that answer and I'm going to square it. So the third root of 8, use your calculator if you need to, is 2, but it's also raised to the power of 2, and 2 raised to the power of 2 equals 4. So that'd be example 1. Let's go over a second example here, or a second way of doing this. Okay. Another format you could have done is said, hey, I've got 8 and it's raised to the power of 2, but it's the third root. So this is perfectly acceptable as well. Taking a look at this expression, all you do is simplify it a little differently. So you would say, hey, what is 8 squared, which is 64? And then use your calculator. What's the third root of 64? Is 4. So there's more than one way to arrive at your numerical answer in this case. All right, let's do some examples, folks, incorporating these laws. Okay, write the expression as a single positive power, then evaluate the power and round to 1 decimal place. All right, so first of all, we have to recognize what law we're going to use, and then we have to see if we can solve it as well. So looking at A, folks, hopefully you recognize we're using the division law, which tells me that I'm going to subtract the exponents. So it's going to be 12 to the power of 2. That's your single positive power. And then use your calculator or your brain. And 12 squared is 144. Okay. Second example, notice our base is a decimal, so 7.2. And it's asking us to multiply, so you're going to raise it to the 3 plus 2. So our simplified answer is going to be 7.2 all raised to the power of 5. Using your calculator, ladies and gentlemen, we're going to round it to 1 decimal place, so you're going to get 19,349, I believe, decimal 2 when you round it properly. Okay. C. Looking at our base is 18, and we have a division law, so it's going to be 63 subtract 63, which is 18 to the exponent of 0. That's as a single positive power, but then to solve it, anything raised to the exponent 0 equals 1. Okay. Question D. Taking a look here, ladies and gentlemen, noticing that we have bases, but we also have numerical coefficients. So we treat them separately. So we multiply first of all the sign. Positive times a positive is a positive. Then the numerical coefficients, 4 times 5 is 20. And then we're going to take a look. Our bases are the same, a and a. So it's going to be a to the power of negative 3 plus 5. Okay? And just make note, folks, that people tend to have confusion. I'm going to show you the difference here between that. People get confused between that and this. Okay. Notice here in this blue example that both 5 and a are part of the base that's affecting that exponent 5. Whereas here, folks, it's 5 times a raised to the power of 5. So that's why you can simply multiply the 5. And this 5 here is only affected by the a, not the 5 out front like it would be here. So if you were simplifying this, you'd have to go 5 to the power 5, use your calculator, plug that in, and then a to the 5th. So there's a big difference between those two, okay? I'll just erase it so that people will understand what's going on here. Okay. All right, simplifying this, folks, we're going to have 20 times a to the power of 2. We can't actually get a complete answer there or a numerical answer simply because we have a variable still. All right, let's take a look at E here, folks. So again, we can break it down to 3 parts. The sign, a positive divided by a positive is a positive. 35 divided by 5 is 7. And then we put the m's together, so it's going to be m to the 1 subtract 3. And then we do our n's, so it's going to be n to the 16 subtract 18. So what do we end up with here? 7, m to the negative 2, n to the negative 2. Remember, it's improper to express final answer with a negative exponent, so you got to move those down. Now 7 is positive, so it stays up top, and then it's m squared, n squared, you form the reciprocal of, and you put it on the bottom. All right, last example here, folks. Here we go. Taking a look here, folks, we've got the bases that are all the same. So it's going to be 2, and we're going to take 5 and add 8, and then we're going to subtract 15. Simplifying that through, it's 2 to the power of negative 2. Can't express it as a negative exponent, so you make it positive. So it's 1 over 2 squared, which equals 1 over 4. Hopefully that's a good review for you guys. Here's your homework, page 61 and 63, numbers 1CF, 2BD, 3, 5AB, 10, and 12. Have a great day, everybody, and of course, see me if you need some help. Bye-bye.